Hey Abby, it's Miss Tracy. So we're in lesson 64 in the first semester. And don't want you to get stressed out about having to watch all these videos. And also, sometimes it helps if you watch the video at a different speed. Like you can do it at 1 1/4 faster so that you can get through it a little bit quicker. Because I know sometimes I ramble and you don't necessarily have to hear all my rambling. But you could do that, or if that stresses you, you can go to your files, your materials in your menu, and you can find the textbook lesson for that and pull it up, and you can read through and look at the example problems, which might help you to do them, because these are the example problems that I do in the video. It's the same thing, I just walk you through it, okay? I didn't create all this stuff. I'm just walking through what is in the textbook. So I'm trying to give you little fun things to help you remember it. With the first part of lesson 64, we're talking about complex fractions, and that's just where you have a fraction in a fraction somehow. A fraction in a fraction is called a complex fraction. Imagine that. So we don't want to have a complex fraction. We want to, simplify it and make it easier. And there's only two processes that you use. It's common denominator or keep it, change it, flip it. So I'm going to walk you through this other problem, or the first problem in the pod that you missed, which is going to be this one. So since you got the first one right, I feel like you have an understanding of what we're trying to do. So let's just go through this and see what we got. So the first thing we want to do is look at see what we have that's complicated. And here we've got a whole number in a fraction and then another fraction. So this is our complex part that we can get rid of. We want to eventually make all of this one fraction. But in order to do that, we have to get rid of the complex denominator here. It needs to be something we can just multiply, right? So this is the one I'm going to take out and move over. 5 plus 2s over z. So in order to make this have a common denominator, so that's my process here, is common denominator, I'm going to multiply everything by z, or the other term by z over z. I'm going to make that a fraction by putting it over 1. So that gives me 5z plus 2s. They're both over z, because they both have the same denominator. So we put that back into the problem. We still have s over z plus 3 over 5z plus 2s over z. Okay, still complicated, but we can change this by using keep it, flip it, change it. I always want to write the f first. I don't know why. So we're going to keep it, flip it, change it here. So I'm going to say that's 3 over 1 divided by 5z plus 2s over z. So when I keep it, flip it, change it, that's 3 over 1 times z over 5z plus 2s, which equals 3z over 5z plus 2s. Okay, so we put that back in as this whole thing now, right? It takes the place of this whole problem. So now we have s over z plus 3z over 5z plus 2s. So now we have two fractions that we want to find a common denominator. So we do what we normally do in that situation. So notice it's common denominator, keep it, flip it, change it. Common denominator, right? So it's just back and forth between those two processes. So now we're going to find the common denominator by multiplying by the other denominator, because we only have two terms, so it's simple. So that means I'm going to have s over z times 5z plus 2s over 5z plus 2s, because that's this denominator, plus, now I'm going to multiply by the other denominator. I've got z over z, because that's this denominator, times 3z over 5z plus 2s. Okay, so we just do that multiplication, and then that's going to be our answer. So s times 5z is going to be 5sz, s times 2s, 2s squared. And then I've got plus z times 3z is 3z squared. And then I have z times 5z is going to be 5z squared. And z times 2s, 2sz. Same thing here. That's the common denominator. You only have to do it once. This is going to be your answer. So you see, it's just back and forth, back and forth. You either find a common denominator or you keep it, flip it, change it. And you just keep taking the denominator out and simplifying it, putting it back in, seeing what you have. Okay, well, all right, I've done this. Let me pull it back out until you get it to one denominator. And then you can combine these terms through the common denominator process. All right, I hope that explains it simply. So 5sz, 2s squared, 3z squared. And I have this set to accept these in any order, so you don't have to stress out about that. 5z squared, 2sz. They're all positive, so you don't have to put a sign in, and that would be the solution. All right, let's look at the next one. Okay, so I thought it would take less time to go through this next one for me to go ahead and illustrate it for you and then walk you through it. And then it might actually be easier to understand because then my thoughts be more organized and I can explain it better. So we started off with this problem and we see we have a complex denominator. Whenever you got a complex denominator, we got to simplify it, right? So the first thing we're going to do, because we have a fraction plus a whole number, we're just going to find a common denominator. So we multiply by the denominator we have, which is c. We multiply the other term by c over c. So we get 2 plus cs over c. We put that back in, takes the place of this whole thing here. So we have 2 divided by a fraction. Okay, so that's still complex because we have a fraction inside of a fraction. So we got to simplify it some more. And this, whenever you have, it's all one term, it's all one fraction, then we keep it, flip it, change it. So we took the top number and turned it into a fraction by putting it over 1 and multiplied it by the inverse or the reciprocal fraction. We flipped it, right? We kept the first one, flipped the second one, changed this to multiplication. So that would be c over 2 plus cs, which equals 2c over 2 plus cs. We put that back in, that takes the place of this term. So now it's m plus that fraction that we created. Now all we have to do is make those two terms combinable. We have to combine them by giving them the same denominator. So we go back to common denominator process. So we have this denominator times this whole value of m. We turn it into a fraction by putting it over 1. We multiply denominator on the top and the bottom, which puts the denominator on the bottom, and then it creates m times 2 is 2m, and m times cs is cms. So we have 2m plus cms plus the 2c we already had, all over the same denominator of 2 plus cs. And that's going to be your final answer. All of these are positive, so you just type in 2m, cms, and 2c in the numerator, and 2 plus cs as the, or 2, and then cs as the denominator. So not difficult. You're simply doing common denominator, keep it, change it, flip it. Or keep it, flip it, change it. Common denominator, back and forth between the two until you get everything in one fraction that doesn't have any fractions inside of it. That is the goal. All right. Next one. All right, here is the next problem. You're going to want to try to do this on your own. I'm going to walk you through the process. We've got a complicated denominator here. So you're going to find a common denominator, make this one fraction, put it back in. So then you're going to have this whole number divided by a fraction. So you're going to keep it, flip it, change it. Once you do that, then you're going to have a fraction plus a fraction. And then you're going to find a common denominator between the two and turn it all into terms divided by terms. So it'd be one fraction. All right, that's the process. So go ahead and do that. And then I want you to pause the video, do that, then press play. When you press play, you will see the answer. I'm going to go ahead and type in the answer for you, or write out the answer for you, so that you can check your work and see where you might have made a mistake. Let's do it like that for the rest of the problems here. Pause it, solve it, and then press play. And then you can easily check your work before you type it in Jupyter to make sure you haven't made a mistake. So go ahead and pause. All right, check your answer. You should have 3 terms on the top, 2am plus ms plus 3a squared. This can be in any order. You do need to make sure you do it the variables in alphabetical order so that Jupyter would mark it correct when you type it in. And then the denominator should be 2a squared plus as. If you got that, then we can go to the next one. If not, then pause the video and look at your notes and see where you might have made a mistake. Okay? All right. So pause now, look at your notes, do what you need to do. If you don't need to do that, let's go on to the next problem. Okay, so here's the next one. M over c plus 8 over 2 plus m over c. So again, the process, simplify denominator, turn this into one fraction, find a common denominator, right? Easy peasy, you can do this. So pause, work it out, and then check your answer to make sure that we have the same thing. If you don't have the same thing, look at the way I solved it, see where you might have messed up, and then we can go on to the next problem. All right, so we took this first section right here, and we turn that into 2c plus m over c. We put that back in here as the denominator. We replaced what we took out with that. Then we took this whole thing, and we did keep it, change it, flip it. So common denominator first, keep it, flip it, change it to make it one fraction. All right, then we did these two common denominators, these two denominators to make a common denominator. We multiply the first term by the second denominator. We multiply the second term by the first denominator over the first, one over the other. And then we multiplied, and this is our final answer. So check your answer and see if you got 2cm plus m squared plus 8c squared in any order, and then 2c squared plus cm as the denominator in any order. All right, if you got those, then we can move on to the next one. All right, so this is the second part of lesson 64. We are into complex numbers instead of complex fractions. And complex numbers are any numbers, any terms or expressions that use something other than a constant and a variable. When they start to use the imaginary numbers or the radical sign, then the numbers are now complex. Which makes sense when you think about it, excuse me. So what we got to do is we're going to simplify as much as we possibly can. And looking at this, it tells us we're going to end up with 3 terms. So let's break this down. So we've got I to the 4th power. We know that I is equal to the square root of -1. And that means that when we have, we know when we have the same number under a radical times itself. So if we have square root of -1 times the square root of -1, that's going to equal -1, right? So anytime we see, as a result, anytime we see I squared, that's going to be a -1. So we've got I to the 4th and I to the 4th, which can be I squared times I squared, because we know that would be breaking, if we were to add those back together, that would be I to the 4th, right? So then we would have minus 5. We've got an I squared and an I, because I'm taking the 2's out, right? So minus 3 times square root of negative 3. So I'm going to say positive 3 and take out the square root of negative 1. So that we have an I over here. And now I've got the same thing. I've got square root of negative 5. Make that a positive 5 and pull the negative out as an I. So that's what we're doing. When we have this negative square root of 3, that's just negative square root of 1 times positive 3. And we can pull this out and make it an I. And that's what we did for both of these. Okay. So now we can simplify negative 1 times negative 1 minus 5 times negative 1 times I. And so we've got 2 of these. We've got negative 3 times a negative 1 times square root of 3 times square root of 5 is square root of 15. So negative 1 times negative 1, that's a 1. Negative 5 times negative 1, that's plus 5i. And then we have negative 3 times negative 1 plus 3 times the square root of 15. And you always want to put this in the right order. And the right order says whole numbers, constants, or order of descending order of the variable. We don't have any variables right here, right? With radicals next. So that would be plus 3 times the square root of 15. Imaginary numbers last, plus 5i. This is the proper format. So you would have 1, 3 to the square root of 15, 5i, just like that. And then it should mark it right. Okay, so let's do the next one. All right, so here we have some distribution. So we're just going to multiply. 3 times 4 is 12. 3 times negative 5i being negative 15i. 5i plus 4, or times 4, they're both positive, so it's a 20i. And then positive 5i times negative 5i, it's going to be a negative 25i squared. Okay, so we can combine these two terms for sure. So it's going to be 12 plus 5i. And then we've got a negative 25i squared. That I squared turns into a negative 1. Negative 25 times negative 1, it's going to be a positive 25. So we're going to add these two together. That's going to be 37 plus 5i, because the imaginary term is always last. That's how you put that in there. And that would be your solution. All right. Next problem. All right, so I would like for you to take the opportunity to try to work this out yourself first. So press pause, solve it, and then come back and check your work by pressing play. All right, you should have gotten a negative 5 and a negative 5i for your solution. If you did not get that, then pause the video and go back through and see maybe where you messed up or missed something. But if you got that, then we can move on to the next problem. All right, so if you got 4 plus 2 times the square root of 6 in that order, then you got the right answer. Good job, you understand what you're doing. If not, go back and look. I to the 4th is I squared 2 times. So it's negative 1 times negative 1 is a positive 1. All right, then we have negative 3i squared. So it's negative 3 to the negative 1, or negative 3 times negative 1, which gives us a positive 3. With that's 1 plus 3, that gives us our 4, right? As our first term. So then we had negative 2 times the square root of negative 2, which we turned into the square root of 2 times I, times the negative square root of 3, or the square root of negative 3, I should say, which turns into a square root of 3 times I. Those two i's make an I squared, so it's negative 2 times a negative 1, and then we multiply the 2 times the 3 to get the square root of negative, or the the square root of 6. We took the negatives out already. Okay, so then that gives us 2, positive 2, times the square root of 6. And then that gives us 4 plus 2 to the square root of 6. I know at first glance, you might want to do over here -2 and square root of -2 times square root of -3. Negative times negative is a positive, and then you would end up with positive square root of 6. But then your 2 would still be negative, right? We can't do that because it's not the same thing. You have to pull it out as a factor. So it doesn't cancel itself. It has to be, when it's under this radical sign, you have to pull it out as its own factor. So when we do that, we're not just getting a positive 1 because it's not a whole number. It's a part of a number, right? So it's just not the same thing. It's not a full-on -1, so it doesn't cancel each other out. We have to pull it out as a whole number, so it would be -2. Square root of -1, square root of -1 would be a -1. So you have to pull that out as a square root to make a whole. You can't just cancel it out and get to a positive square root of a positive 6. You still have these two partial negatives that you're dealing with. It just doesn't work the same way as a positive number. It has an impact that's different. And that's why we use the letter I to pull it out, because you can't get there. You just can't get there. It doesn't work the same way. Okay? I know that's a little confusing. But I don't want you to get this. This should be a positive sign, not a negative sign. If you don't pull it out, you get a negative sign, and then that doesn't work. It doesn't work. I don't want you to get to thinking that you could say, oh, -1 times -1 is going to be a positive. It's not. It's a -1 whole number. So -2 times -3, that's still a -6, but the negative is squared. So it's a little weird, right? Okay. All right. You should have gotten this. If you didn't get this, then ask me a question. The part that confuses you, ask that question. All right. Next problem. All right. Again, go ahead and see if you can solve this on your own and check your answer. See if you get the same thing I got. If you did, we can move on. If not, we can pause it and look through my notes to see where you might have made a mistake. And keep in mind, as I'm doing these notes, I'm also double checking the answer key to make sure that I'm right, so that I'm giving you the same thing, the right thing, okay? All right, you should have gotten -66 plus 2i. If you did not, then pause and look through what I did. This -4 cubed is going to be a -64, which is this. This is square root of positive 4i plus square root of positive 2i, square root of positive 2i. Those times each other gives me a 2. The i's times each other gives me I squared. Square root of 4 is 2, so we have 2i plus 2i squared. The 2i stays the same. The 2i squared, this becomes a -1. 2 times -1 is -2. So I combine the -2 and the -64. I get -66, which we write first, even though mathematicians are lazy, because the imaginary number has to come last. And that should be the order you type it in, -66, 2i. Next problem. All right, you should be getting the hang of these by now, but go ahead and solve this one. Come back, check your work, press play to check your work. I'm going to pause, solve it, and then have it ready for you when you're done. All right, you should have gotten a -3 plus 13i. So you have square root of 9i. Not square root of 9 is 3. 2 times 3 is 6i. Keep the I with it. And I squared times I squared is a +1. This -1 times -1 is +1. So technically, if you have I to the 4th, you can just cross it out. It cancels each other out. It makes it a +1. So the -3 remains the same. And then we took the I out of the second square root of -3, or the second square root. So we had square root of 3 times square root of 3. That's going to be a constant of 3. So 2 times 3 is 6. We still have that I, and plus I, right? That's a 1i. We know when we have a variable of any kind, there's an by itself with no number. The number in front is 1. Mathematicians are just lazy. They don't write the 1. So 6 plus 6 is 12, plus 1 is 13. Don't have anything to combine this guy with, so it's -3 plus 13i. Next problem. All right, so solve this one on paper, and then press pause, solve it on paper, just like we did before. Come back and check your work and see how you did. If you have any questions, always be able, know that you're always able to ask me questions, and I will be there to help you, even if you get in college algebra, sweetheart. All right, for this one, you should have gotten 19 plus 9i. I rewrote this distribution problem where I took the first term and I multiplied it times the second binomial. Took the operation plus 3i times the second binomial. Sometimes when people are struggling with distribution, I don't know if you do or not, but I thought I would show you this technique just for the sake of it makes you see it easier, right? So now you just have to multiply 2 times 5 and 2 times -3i, which gives you 10 minus 6i. And a +3i times 5 is a +15i, and a +3i times a -3i is a -9i squared. Well, the I squared becomes a -1. -9 times -1 is now a +9. So 10 plus 9 is 19. -6i plus 15i is 9i, positive. So you have 19 plus 9i, and that is your solution. If you did not get that, check back, see where you maybe dropped a sign or something to correct that. Next problem. All right, again, more distribution. So I'm just going to, well, I forgot. I want you to pause the video and go ahead and solve it, and then press play, and then I'll walk you through it, okay? All right, you should have gotten -22 minus 14i, right? Those should be your two values that you got. Now, I know it says plus in between, but we know that whenever we have terms that are negative, we're just combining positive and negative terms. Everything is addition. It's just addition, or addition means to combine. So we're just combining positive and negative terms. So don't let that throw you for a loop that I had a positive right here. Okay, you're just put in the terms sign for the term in the blank, and it still works the same way. If you think of these as parentheses, then it works. But that should be your solution. I just separated it so that you could see the distribution more easily. We get 6i, and then 3i times 4i is 12i squared. Well, that becomes a -12. So 6i minus 12 is from the first set of distribution. The second term distribution, -5 times 2 is -10. -5 times a +4i is a -20i. So when I combine everything, these two make a negative 22. These two combined make a negative 14i. Thus your solution. Next problem. All right, so the one blank here should tell you that you are going to have one term at the end. So for the sake of that, you know, that should you should wrap your head around that. I'm going to let you go ahead and solve it, and then press play, pause it, solve it, press play to check your work. All right, your solution here is going to be negative 10. So we have 2i times I plus 2. So that gives you 2i squared plus 4i. Then you have negative 4 times I plus 2. So that'd be negative 4i, negative 8. So these two guys cancel each other out. 2i squared is negative 2. Negative 2 and a negative 8 is a negative 10. And that's your solution. Cool, huh? Next question. Okay, so now we had a video, lesson 65. We're in advanced substitution, and all we're doing is our advanced substitution is where we have two variables together that equal something, and we're looking for that combination of those two variables in order to substitute the value that we have for it in. Again, we're just playing a matching game. You're matching the letters to the number value. You find that letter combination, you put in that number value. Just like we've been doing, but with subscripted variables, it makes it look harder than it really is. You're writing down all these letters in, it's like, you know, it looks complicated because there's so much you're writing down, but it's not. You're looking for one matching set to put the number in that matches it. Okay, that is all this is. And you're using what you know, just like normal, to find what you don't know. So you can look at this. This is in your material section, lesson 65, if you need to read through this better instead of watching the video. All right, so let's go over here to the first problem. So we're going to find the value of all four variables in this system of equations. So we have some givens. We have RPTP equals 288. RCTC equals 108. So we know these are not equal to one another, right? RP equals 3 RCs, and TP plus TC is equal to 12. Okay, so right away, I see that I can make a substitution value here. So I'm going to do that. I'm going to subtract TC from both sides. TP is now equal to 12 minus TC. So there's a substitution value that I created that they did not give me. Now I'm going to look at these, and I have a value for RP. I have a value for TP. So if RP TP is equal to 288, I can take RP and put it in. So for RP, I'm going to put in 3 RCs. For TP, I'm going to put in 12 minus TC. Just substituting away, right? And I know you're sitting here thinking, that's two different variables. How am I going to solve for that? I've got an RC and a TC. How is that different from what I had up here? Because we have a value for RC times TC. So when we get to that point, we'll discuss it, okay? So 3 times RC times 12. 3 times 12 is 36. So 36 RC is the first term. Now we have 3 RC times a negative TC. So it's going to be a negative 3 RC TC is equal to 288. Guess what? RC times TC, we know what that is. That's 108. So 36 RC minus 3 times 108. See how that works? We use this combination of two variables. We found where that we match that, and we put the number value in for it. That is what we're doing for all of these. We're substituting in what we have in this set, right? And it's always smart, if RP is here, if this little p is here, you want to make the TP the one that you solve for, not the TC. because otherwise it won't work. Does that make sense? Otherwise it won't work. You're looking to find, what is this one? Let me get its partner to match it. Then you can drop those in. That's the strategy. Okay, that equals 288. All right, let's find out what is 3 times 108. It's going to be negative 324. So 36 RC minus 324 is equal to 288. I add 324 to both sides to get RC by itself. 36 times RC is equal to, this is 12, carry 1, this is 11, carry 1, this is 6. So I divide both sides by 36, right? Now divide. 612 divided by 36 is 17. So RC is equal to 17. Ha ha ha. Now I can find out. Now I can find out what RP is. So if RC is 17, RP is equal to 3 times 17. And that is going to be 51. So RP is equal to 51. So that is the first thing I would do. I've got my RP is 51. My RC is 17. I've got those two down. Now I can use those to find the others. So I've got RP is 51, right? RP, TP is equal to 280. RP times TP is equal to 288. So I don't know what TP is, but I know this is 288. Divide both sides by 51. That's going to give me the value of TP. So 288 divided by 51. That's a fraction. It's going to be a fraction. I think that's the way it stays too in the book. Let me double check. I hate it when they give me fractions. Why must you give me a fraction? Why can't you just leave it? Yeah, it's a fraction. So, because you know it's a fraction when you get a decimal, right? I hate those. But we can reduce that. Let's see, what can we reduce that by? I think I can reduce that by 3. 288 divided by 3 is 96. And we already know that 3 times 17 is 51. So if I reduce 51 by 3, it's going to be 17. So 96 over 17 is TP. 96 over 17. So I know that RC is 17. So 17 times TC is equal to 108. And I got that from right here. I just put in my 17 here. All right, 17 TC equals 108. That's the same thing. I just did it here. So if I divide both sides by 17, I get TC is equal to, and 17 is a prime number. So that's not going to be able to be reduced. So the answer is 108 over 17. You can't take that down any further. So TC is 108 over 17. Dunsies. All right, that's what we're doing for the whole thing. We're finding a way to substitute in something to give us one answer, and then we start breaking down all the others. That's all we're doing. All right, let's do the next one. Okay, here's our problem. We got RWTW is 8 and RBTB is 8. Ooh, those are equal. If we wanted to, we could say RWTW equals RBTB. We could do that. We already have a substitution value for TB. We already have a substitution value for RB. So RB and TB are together. So we can substitute that in. So I'm going to take this one RBTB, actually I don't need to rewrite it. That's just me being silly. So that's going to be 4 times RW for RB, and then TB is equal to 2 minus TW. We know that equals 8. So 4 RW times 2 is 8 RW, and 4 RW minus TW is a negative 4 RW. TW is equal to 8. All right, RWTW is 8. So 8 times RW minus 4 RWTW, that's 8, equals 8. So that's going to be a negative 32. 8 RW minus 32 is equal to 8. Add 32 to both sides. So 8 times RW is equal to 40. I know that 40 divided by 8 is going to be 5. So RW is equal to 5. All right, so if RW is equal to 5, I'm going to have some fractions up here. So RB is equal to 4 RWs. So that's going to equal, RW is 5, 4 times 5, which is going to equal 20. So RB is equal to 20. RW is equal to 5. So we got those two. Now we just got to find out what the others are. And we're going to break those down using these original terms. So RW is 5. We don't know what TW is, and that equals 8. Divide both sides by 5. TW is equal to 8 over 5. That's as far as we can go. 5 is a prime number. We can't break it down any further. Now let's look at RBTB. So RB is equal to 20. 20 times TB is equal to 8. We got that from here. So if I divide both sides by 20, TB is equal to 8 over 20. I can reduce that by dividing everything by 4. So TB is equal to 8 divided by 4 is 2. 20 divided by 4 is 5. So TB is 2 over 5. See, these are not so hard. They just look hard because you've got all these variables running around and you're not really given a whole lot of numeric value to start with. But you can do it. You just have to get it to the point where you can substitute a second time using the values you're given. All right, not super hard. Next one I want you to do by yourself. All right, so find the values of all 4 variables in the system of equations. I would like for you to pause the video, and I would like for you to solve it on your own, because I know you can, and then come back, press play, and check your work, and we'll see if you got the same answers I did, then you understand what's going on, and you're able to do them. If you did not get the same answers that I did, then we can go through, you can go through the notes, or you can fast forward and get to the next problem, okay? All right, so let's pause the video and go for it. All right, so what you should have gotten is that RP is equal to 75, TP is equal to 8, RC is equal to 15, and TC is equal to 7. If you did not, then let's look. All right, so we have our given values. We created a substitution value from TP plus TC equals 15, so that TP is equal to 15 minus TC. So we pulled the RP TP equals 600, and we substituted in the value for RP, which is 5RC, and the value for TP, which is 15 minus TC. That created a distribution problem, which gave us 75 RC minus 5 RCTC is 600. So we took the value for RCTC, which is 105, and substituted it in, multiplied that to get a negative 525, added that to both sides so that we could get 75 RC is equal to 1,125. Divided both sides by 75, RC equal to 15. So once we had the value of RC was 15, which I went ahead and wrote, Then we went back up here to RP and said 5 times RC, which would be 5 times 15, would equal 75. So RP is equal to 75. So then I wrote that in. So then all I had to do was come over here to RP TP equals 600, and I put 75 in for RC, or RP. 75 times TP is 600, divided both sides by 75. TP was equal to 8. I did the same thing for RCTC. I took the value of RC, put it in, right? 15 times TC equals 105, divided both sides by 15. TC is equal to 7. So that's all you're doing. You're undoing, finding the substitution value, dropping it in wherever you can, and solving. Right? Let's do the next one. All right, so this is the last one of 6465. Hallelujah. We've been at this 45 minutes already. So hopefully you were able to skip some of my explanations because you got some of the right answers. Let's do that again. Solve it on your own. Check your answers. If your answers are different, then you can watch the explanation. If not, if you got them right, then you can be done. Hallelujah. All right, so go ahead, pause the video, and solve it for yourself. All right, so you should have gotten that R1 is 60, T1 is 2, R2 is 30, T2 is 4. If you did not, then if you did, you're done with this video, turn it off. If you did not, let's go through it. So first I created a substitution value for T1. That allowed me to say T1 is equal to 6 minus T2. Then I took that, given that I had R1 and T1 a substitution value, I took R1, T1 to solve, right? So R1, T1 equals 120. And I color-coded this to make it easier to follow. So R1 is 2R2, and T1 is 6 minus T2. So 6 minus T2 equals 120. All right, so I've got 12, 2 times R2 times 6 is 12R2, and 2 times R2 minus T2 is 2 times R2 T2. R2 T2, say that 10 times fast. So R2 T2, we see up at the top here, is equal to 120. So we drop 120 in for that value. So then we have 12 R2 minus 2 times 120, that's a negative 240, is equal to 120. So we add 240 to both sides, we get that 12 R2 is equal to 360. Divide both sides by 12, R2 is equal to 30. So I come back up here and I write in 30 as the value of R2. Well, then that allows me to come over here to R1 and drop 30 in as the value for R2. So 2 times R2 is equal to 2 times 30, which is equal to 60. So now I can put 60 in for R1. Those two values allow me to take the original R1 T1 equals 120. I can take the value of R1, which is 60. I drop that in. 60 times T1 equals 120. Divide both sides by 60. T1 is equal to 2. All right, now I can take the R2 and drop it into this problem. R2 T2 equals 120. R2 is 30. 30 times T2 is equal to 120. Divide both sides by 30. T2 is equal to 4. So now I have my value for T2, which is 4. And you can double check your answer. If R1 times T1 is 120, 60 times 2, that's 120. R2 times T2 is 120, 30 times 4, that's 120. So we got it right by checking our work. We know we got that right. So that is the last problem. Hallelujah, you're done. Thank the Lord that this was not, it's not super difficult. Mainly it's just time consuming and it takes a lot of paper. It's not hard so much as it's complex in the way it looks. But if you can wrap your head around the fact that they're just variables, R1 is one variable, T1 is one variable, and you can just kind of wrap your head around that, then you'll be fine. Okay. And I highly recommend color coding on your paper when you go from one problem to the next problem within the same problem, because then you can follow your thought process a little bit better. I know it works for me. I thought to apply it here simply to show you a technique that I use, and that I taught my kids to use when solving a lot of stuff, because otherwise, if it's all the same color, it can run together and you can get confused much more readily. But you see, having these 3 different problems be 3 different colors, it's not as difficult looking. It's very simplified. And you know where you are, right? Okay, so I'm done with the rambling, hopefully, and I'm done with this video 6465. And I'll do another video for the other one, 60, is it 66 or 68 or 66 and 67? I forget, but I'll do a video for each lesson, like each pod, not all of it at once, which is a good thing because this one's almost an hour. It's 51 minutes. I'm so sorry for taking all your time, but I hope this helps you get ahead. Okay, sweetheart? Fast forward these as you need to, check your answers, and then if you got them right, skip on over to the next problem, and just ask questions where if you get to the point where, oh, I understand how these work, then just move on to the next video, right? Do the work and knock it out. I just want to give you as much as you need. I want to give you all that you need. You take from that the part that applies, okay? By that I mean, if I start getting boring and redundant and you know what you're doing, cut me off. Do the work, move on to the next lesson. I don't want to overwhelm you. All right, that's all I've got. I will see you next time. Bye for now.